Okay, in this problem, a chef is choosing from 12 entrees, 3 of which have spinach, so the other 9 do not. The guests will have a choice of 4 entrees, and if the chef chooses 4 of them, part A, what's the probability that at least one has spinach? Now, I want to focus on my hint here just for a little bit. Not red. Where I say complements will help. So, we're using a capital letter to represent an event. So in this case, our event is at least one dish has spinach. So more specifically, our event A is 1 or 2 or 3 have spinach. So at least 1 means 1 or more. So there's a total of 3 with spinach. So our event is 1 or 2 or 3 have spinach. Now, the complements, that's given by A bar over here, the complement of at least 1 has spinach, you can think about them in terms of opposites. The complement would be none have spinach, or 0 have spinach. Now, the benefit of using a complement when it applies is that sometimes the number of ways your event does not happen is easier to count than the number of ways your event does happen. So in this case, our event is at least 1 has spinach, but the complement of our event, none have spinach, well, that's easier to deal with because there's only one case. And since the probability of A plus the probability of not A, these two together have to add up to 1, then if we have 1, that basically gives us the other one. So the probability of A should be 1 minus, 1 is the 100%, 1 minus the probability of not A. Okay, so, for example, if not A has a 30% probability, well then A has the 70%. If not A is 60%, then A would be 40%. So if we have 1, we have the other. So we just calculate the one that's easier to calculate. Okay, so what is the probability that none have spinach? Well, how many ways can we choose 4 entrees out of the 12 if none of them have spinach? So let's say over here, probability of not A. Okay, well, by definition, probability is the number of ways this could happen. And let's see, we're choosing 4 entrees out of, well, there's 12 total, minus the 3 with spinach. So there's 9 entrees with no spinach. So the number of ways we could pick 4 entrees where none have spinach should be 9 combination 4. This will tell us total number of groups of 4 out of the total group of 9. And in the formula for probability, the denominator is the total number of ways your event could happen. So how many ways can we pick any 4 dishes out of the 12? So that should be 12 combination 4. I'll go over to Excel to do the calculations here. So 9 combination 4, that is 126. So that's 126. And on the bottom, let's change that 9 to a 12. 495. 495. And again, we could do our calculations in Excel. Equal 126 divided by 495. Okay, and let's round this to maybe 3 decimal places, 0.255. So this is the probability that our event does not happen. So if we take 1 minus this number, this should be the probability that our event does happen. So P of not A is 0.255. So let's come back over here. Is 0.255. So let me switch colors here. So the probability that A does happen should be 1 minus 0.255. 0.745. And that gave us the 0.745. Okay. So that does it for part A. Part B and C are a little bit more straightforward. In part B, what's the probability 3 have spinach? Okay, well, if there's 4 entrees to choose from, if there's 4 entrees to select, so entree number 1, 2, 3, and 4. The first 3, there's only one way to choose them because there's only 3 spinach options and we have to select all of them. So there's going to be a spinach choice, a spinach choice, a spinach choice. So there's only one way that could happen. And for the 4th option, now there's 9 more options to choose from. So 1 times 1 times 1 times 9. So if we're looking at this as a like fundamental counting principle, there's basically 1 way to do this and 9 ways to do this. So 9 ways this could happen, which means the probability, let's go back to the definition of probability. The probability of, I'll say 3 spinach should be 9 divided by 12 combination of 4. And we already have that. That's the 495 we calculated in part A. So pop this into the calculator, whatever we get, 9 divided by 495. I'll leave that to do on the side. And now the last one, part C, what's the probability all 4 have spinach? Well, there are only 3 options with spinach, so this is an impossible event, and we said the probability of an impossible event is 0. So for part C, the probability that all 4 have spinach is 0. Okay, that does it for number 2.